Hi there, my name's Keith, and we are back here with another one of Keith Barker's Cisco Packet Tracer Practical Labs. This one today will be focusing on implementing a static NAT and dynamic PAT and troubleshooting that through the created network that we have here. Now, what I like to always do in the beginning is just to have a look around, especially a network that I haven't created myself. I always like to just have a squeeze at our end client devices and our switches and routers and just have a look at what has already been implemented. You don't want to be implementing something and then all of a sudden you don't know why something's not working. So I'm just going to go right through and just have a look at our client, our end device, our client PC. Now, see we've got a gateway here, 10.10.03. We've got a DNS server statically assigned, I believe, which is this one in the corner here. And if we go to interface, we see we've got a statically assigned IP address as well, a 10.10.0.10, and we've got a /24 subnet mask. Okay, looks all pretty good. Now, so we've got, assume these are layer 3 switches. Let's have a look at this, see if it's going to come up. Alright, I'm going to maybe check our layer 3 switch. Okay, so we've got, I assume we've got one network on the 10.10 and another on a 10.20. So I assume we've got that being our 10.10 and this being our 10.20 network. So now that what I like to do as well, especially when it's this, I like to do a little scribble as well. We've got another one on this side. Cool. This is more just a visual thing to help me just see where our separating networks are, just in case I get a bit lost in it. Okay, and I just want to place a note here, 10.10.00/24. Place that one there, and 10.10. Let's actually just double check that. I'm assuming that's a separate network based on these multi-layer switches. That's what MLS stands for. There we go. Yeah, so we've got one network on a 10.10 and we've got another network on a 10.20, and they've got their respective VLANs as well. So it's 10.20.00. Just add that on there. Also a /24 subnet. Oh. Just place that there. Cool. Now, I just want to check. If I can spell. So we've got our two VLANs that are up. Now I just want to see if we can ping from our multi-layer switch to our client PC. And that's just going to tell me that A, this multi-layer switch is configured correctly, and that the switch here is configured as well and is able to reroute that packet to the end client PC. So if we go back to our layer 3 switch, and we just do a simple ping 10.10.0.3, I believe it was. Cool. So we see it, we do have connection between our multi-layer switch and our switch there and our end client device. So that's telling me essentially that this portion of the network is functioning correctly, and that I can ping to the end client PC and I can potentially get data from the end client PC back to that switch. So that's a positive. Now I see these two are connected as well. Just want to have a look and see. Yeah, they're pretty much identically set up in terms of our VLANs. So that's all good. Now, question is, are we able to also ping the end client from this? Yes. Okay, cool. So now, essentially, from that we can tell that that portion of our network is functioning fine. Everything seems to be all right there. So now I'm going to jump onto this edge router and just have a look at and see what has that been configured. So we've got a gigabit Ethernet that is assigned to 23.1.2.1, and then we've got our gigabit Ethernet 1 that is assigned to a 10.20, which is our network in here. So I think I've got to just edit this. So that network essentially finishes there, and then we have a third, or the outside of our local network. We've got our server, and let me just double check that. Just close all these. Just double check that's right. 23.1.2. Oh, network. Put it down here for the time being. All right, so let's go back to our edge router. So everything seems to be all right here. What if we try and ping our PC from this side? Okay, so it seems that we can, from our edge router, we've still got connectivity through to our end client PC, which is a good thing. Now I just want to confirm that that is indeed a /24. So if you go show run show run section interface. Why did that not work? Show run. Show run. Section. Include. Complete command. Cool. Took me a hot minute. All right, so we can see that it is indeed a /24 subnet, so we were lucky there. We see we've got a VLAN there as well, which is fine. So I just want to double check on our client. Let me just see. Just want to make a note of that. 23.1.2.2. I just wanted to see if we are able to ping that apologies. Okay, so we've got a destination host unreachable, and it looks like it has come from our multi-layer switch, which I believe it was one of these, if I can remember. Yep, it was from our default gateway from our layer 3 switch, or multi-layer switch, sorry. Just want to see if, okay. Okay, so essentially we can ping, or we have connection to everything in this network. We've got everything in this network, and it's just a case of getting from our edge router to our server. That seems to be our issue here. So only option will be to have a look at our that seems to be fine. Oh, what do I need to look at? Okay, so if I just look up our show IP route. Okay, gateway of last resort not set. Okay, so we can see that our multi-layer switches have on their table, they have our 2 networks, but they don't have this 23.1 network. So what we can do is on our edge router, now I believe we have OSPF functioning between our multi-layer switches. So what we can do is, if we go, just check here. Yeah, so we've got our edge router has our outside network on its table. So essentially all we have to do is tell our switches that, hey, if you want to get to this server or get out, your default gate or your way is through this edge router. So how we do that is, if we go back, is if we go into our config and then go and we go interface OSPF1, no, I recognize command. Go out, go back in. There we go, OSPF1. And then we go default information originate. And we go back to our we can now see that we have added via OSPF, we have told our edge router, hey, advertise your gateway to our outside network to these switches. So then if we ping off our client PC, that should not stop at our multi-layer switch anymore. It should be able to forward it through to our DNS now that it has an address to actually send that packet. So if we try and re-ping that DNS server, let's see if it's going to work. It's not looking good. Okay. What about that default? What about our packet? Okay, cool. So we essentially can ping all the way up to here. We can get out of our edge router, but we still cannot connect to our DNS server from our client PC. So how we are going to fix this is we can assign a static NAT from our edge router that will be essentially our gateway to allow our PC to talk to our DNS, which, if we look at our lab's objectives, is to implement a NAT/PAT on edge router so PC1 can open the web page for a server at keithbarker.com, which is on here. It also states that we have to leave the server itself with no default gateway. Normally, a simple fix would just be adding a default gateway on our server and then adding it to our router. So then if we send a packet from our PC all the way through, the router has it on its table that, oh, okay, that information that it wants to send through is on the DNS, and this is its gateway. So that's not what the practical wants us to do. It wants us to implement a NAT, or implement a static NAT in this case. If we go show IP show IP NAT, I'm still in the, goodness gracious me, show IP NAT stat, which we see we've got nothing because there is nothing coming up. If we go show IP show route section NAT IP section NAT, no. Show IP there we go. Took me a while. All right, so from here we need to go into our global config, and we need to assign first of all we need to assign an IP address that's on the inside, and an IP address or the connection that is on the the outside of our network. So we need to tell our Giga Ethernet port 0 that it is the outside IP net outside. Cool. And just to confirm that, we can see that it has now assigned that Giga Ethernet 0/0 as our outside of the interface, or outside our router. And then we'll do the other Giganet Ethernet 0/1 as our inside of the network. So go inside. Cool. So now if we run our show IP NAT stat again, we can see that we have now assigned our gig 0/0 as our outside interface, and our gig Ethernet 0/1 as our inside interface for our static NAT. And now finally we need to just assign the translation. So if we go config and then go if I just double check something real quick, you go IP NAT inside source, which is this side, static. I'm going to statically assign it, and we're going to use our PC's IP address, which is 10.10, not what I was putting down. 10.3, and then our outside, which is outside, which will be on this client or this server, sorry's IP address. Now, our practical has not stated what IP address to use. So I'm going to assume that 23.1.2.1 is for our default gateway. So we're not going to be using that. Our .2 has been statically assigned to our DNS server. So we can arguably say that we could potentially use a 23.1.2.3, which is the next one in the IP address list. Or we can, just for fun, we can do a 23.1.2. Let's just marry it up with our client PC and we'll just match it. And we'll hit enter on that. Oh, I did not need that outside input on there. Cool. So now if we go out and we go show IP NAT, we can see that we have our inside outside. And then if we go show run IP NAT, we can see we have our IP NAT sources stat at our client PC and our outside is our server. So now that we see that we have that's something that's been assigned there statically, we can now go back to our client PC and we can now attempt to ping our DNS server once again. As you can see, our last attempt was a fail, but now with our statically assigned NAT on our edge router, that's able to translate our inside IP address network of 10.10 to a 23.1.2.2 network, or sorry, 23.1.2.0 network. It should be able to connect now. So if we run that, we can see that our client PC can now connect to our web/DNS server. And then another way that we can confirm that is if we run a show IP NAT translation, and we can confirm that our particular client or end user PC has gone through our traffic and it has gone to our edge router, and our edge router has translated that 10.10.0.10 IP address into our 23.1.2.10 IP address, allowing it to exit out of that internal network and into the external foreign network of the 23.1.2.0 network. So now if we head back to our PC and we head to our web browser to confirm that we can indeed reach our web server, which is we can. Alrighty, so now that we have configured our network with a static network address translation protocol, I'm going to show you how to do it with a dynamic PAT. Now, first thing we're going to do is remove our, just show everyone. Okay, why did that not work? Let's remove our Static NAT pool. So I'm just going to copy that one. And all I'm going to realistically do is just go no and paste. Now you can see that we have removed our static assigned addresses, and now we can start implementing our dynamic PAT. Now we can do it in either two ways. We could either do it as a pool, meaning we have a few IP addresses that will be dynamically assigned when our client PC is going through our network and out to our foreign network, or we can do a static one where we assign a singular IP address. Now, in a small office home setting, a statically assigned PAT address would be fine, but in an enterprise where you have multiple end client PCs, that's not necessarily ideal, as you have multiple or even hundreds or thousands of client PCs trying to exit through one IP address as your way out, which essentially will bottleneck your network. So I'm going to show you guys the method where we assign a pool of IP addresses to our edge router. All right, now I just want to confirm that we do have indeed lost connection, and we have removed our static NAT configuration, which seems like it has lost its connection, which is fine. I'm just going to let that run out real quick. Yep. All right, so we lost 100% loss. That's all good. So now that we know we've removed our previous configurations, we can start with our fresh one. Now, first of all, with our dynamic PAT pool, we need to assign a list. So we are going to first of all create our list. IP access list standard, and we're going to give it a name. We'll just call it Keith PAT or dynamic PAT, and hit enter. And then we're going to permit our inside network, which is this one. Excuse me. And it's available user list. Sorry about that. Which will, double check that. There we go. that will give us our list. So now if we now do a, let's back out. Show run section Keith dpat. Careful with the cap sensitives. We can see that we have our list. So now we're going to configure the pool, which is the addresses that this network is going to be able to pull from in order to go out to this foreign network. So if we go back into our config and we go IP NAT pool, let's call our pool name Keith pool, and now we can, with our pool, we can assign 1 or 5 or 10 addresses, depending on how your network layout is. We can go right to the end of it, or we can do a pool of maybe 5 or 10. So I'm just going to do a pool of 10. So I'm going to start at 23.1.2.50, and we're going to do our 23.1.2.60. Make sure we add our net mask, which is 255, 255, 25. Oh, yep. 0. So now, if we exit and we show our IP, show run, we can see we have our pool there. We can see we've got between our 23.1.2.50 to 23.1.2.60. So essentially, anytime we now leave, our edge router is going to assign one of those 10 IP addresses to our client PC when exiting to this foreign network. And then finally, we're going to marry up those two configurations with our access list and our pool. So if we go back into our terminal, go IP NAT inside source, and it's going to be our Keith dpat list. Keith dpat. Pool, Keith pool, and then we're going to add our overload command. Oh, what have I forgotten? Did I caps lock it or did I not caps lock it? I needed to specify the list. Cool. So if we go out and we show our IP, show run IP, section IP NAT, and we can see our NAT pool and our list married up. And then we can do a show IP NAT stat to have a look closer into it. And we can see a bit more in depth that our inside source, our access list, Keith DPAT pool, we've got none that's currently assigned. But you can see we've got our start and our end. We've got a total of 11 addresses that our edge router can use to outbound these internal packets. And see we've got 0 allocated at the moment. So if we run now a ping back to that server, we can see that we are able to reach it now. And if we go back to our router and we do a IP NAT stat, you can see that we have actually assigned one of those addresses to our end piece, our end client. So we go show IP NAT translation. You can see that we have our inside local client PC going outbound via our assigned IP address, which was our first one that's available to us, which is the 23.1.2.50. Now, if I have multiple client PCs here, you'll see that we'll have more allocations. Obviously, with this address pool, we can only have up to 11 clients, but we can make that bigger or smaller depending on our network size. But finally, same as the static NAT configurations, I'll just run our connection to our Keith Barker webpage as per our lab objective. And you can see we are able to reach it now. So those are the two ways, adding a static DNS here or here. And yeah, thank you so much for watching, and I'll see you on the next one.